Welcome to today's lecture on collision theory and logic. This lecture is brought to you by Lake Minneola High School, and it is designed for the Game Simulation and Animation Foundations course. Our essential questions for today are: how does collision theory apply to game programming, and how does it apply to real-world situations? First, what is logic? Logic is defined as the set of instructions of a program that allows a program to execute correctly. Programs with syntax errors cannot execute. Programs without syntax errors can execute, but may not produce the intended results. Programs designed with logic and lacking syntax errors can execute to provide expected results. Essentially, this means not to leave out any instructions and also not to have any extraneous instructions. Programs with syntax errors. Let's take an example of baking a cake. Looking at some of the simple instructions, do not attempt this at home, but looking at some of the simple instructions, we have stir, add 2 eggs, add a gallon of gasoline, bake at 350 degrees for 45 minutes, add 3 cups of flour. As you can tell, there are a few errors here. First, we're adding a gallon of gasoline. This is an extraneous instruction. This piece of logic does not fit into cake baking. If you make a cake with a gallon of gasoline, you're poisoning your cake. Again, do not try that at home. Second, we can see that there are several syntax errors. There are several errors of spelling. And when you're looking through the program, the computer is reading the code as it is spelled, and it is looking for exact characters. If you have spelling errors, your code cannot execute. So prior to this program executing, all the syntax errors must be corrected. So looking at a program, again, looking at the cake baking scenario, but without the syntax errors, we have stir, add 2 eggs, add a gallon of gasoline, bake at 350 degrees for 45 minutes, add 3 cups of flour. Looking at this recipe, we can tell that everything has been fixed in terms of spelling. However, it has extraneous solutions, and this extraneous solution is what we would call a logical error. The logical errors are much harder to find in a code because they can execute, they can work. However, they are not making the program work as expected. So what you're trying to do is get the entire program to work as expected. You must find the logical errors, and these are, again, much harder to find than syntax errors. So programs without syntax errors continued. If we look at baking a cake, we have add 3 cups of flour, add 2 eggs, stir, bake at 350 degrees for 45 minutes. This program uses the correct English syntax, and it also uses the correct sequencing, and it does not contain any extraneous instructions. This is very important for executing a program, either in the real world, such as baking a cake, or in creating a program for a computer. So when you're looking at this, you must make sure that you have the correct English syntax, the correct sequencing, and that you do not have any extraneous instructions or logical errors. So moving into more programming, if we have our logical statements that create a set of instructions for a specific application, what we're looking for is if-then conditional. We call these conditional statements. So, if we have the following code, it says, add 3 cups of flour. If flour is added, add eggs. Then it says to add 2 eggs. Next it says, if flour and eggs are added, then stir. And then you stir. If stirring has occurred, then bake at 350 degrees for 45 minutes. And the action here would be bake at 350 degrees for 45 minutes. Essentially, by looking at these if-then statements, what we're saying is, if a condition is met, do some action. That's exactly how conditional statements work in the real world, as well as in computer programming. So collision theory. Collision theory is defined as the reactions to a colliding action. Originally, this is applied to chemistry to explain particle movements. and it applies to program design, especially in games where action-reaction statements are used quite frequently. Collision theory is used by game designers to create a realistic reaction to game actions. Simple game actions of a player colliding with a wall object in pseudocode is as follows. We have a player is moving, player collides with wall. If player is moving and collides with wall, then player movement is stopped, and it says return player movement as stopped. If player movement is stopped, end the program. Thus you end the program. Now this simple set of pseudocode, or code known as native language for programmers, what we're doing is we're creating a simple scenario, and we're outlining what we have as far as an action, another action, a conditional statement, and if that conditional statement is true, then we have an action. Then we have another conditional statement. If that conditional statement is true, we have another action. The process of programming is very similar. Hence we use the pseudocode. We also use graphical organizers or pseudocode flowcharts to create a visualization of how our code is working. Flowcharting helps developers to visualize the code prior to its development. This way they can work out any bugs that they need to before the game or the actions are ever made. As an example, continuing with what we had before, we have the program begins and then the player is moving. Next we say player collides with the wall. If yes, the player movement is stopped. If no, the player movement is still going back and it rotates backwards to player is moving. And then it tests the same condition again. The next part, let's say our player collides with the wall. We move forward, the player is stopped. If the player is stopped, we ask yes or no, is the player stopped? If yes, we end the program. If no, we go all the way back to saying the player is moving, and we test all of our conditions again. What we're doing is we're simply saying, look at the program, look to see if we're testing certain conditions. If those conditions are true, do certain actions. If those conditions are not true, continue doing the previous action. So now we're looking at actual code. So player movement is further explained in code, and code is the language that is used by the development platform to translate commands into machine language. There are many different coding languages. So what you see here is simply ActionScript 3.0. For example, it says variable player move is a boolean and it's initially set to a true value. It says if, going to a conditional statement, the player X position is equal to the wall X position, meaning the player collides with the wall, then the player movement needs to be set to false. Otherwise, or else, the player movement is true. Looking at the next conditional statement, it says if the player movement is false, we want the program to stop. We have fs command quit. What this is simply saying is the previous slides where we had our pseudocode, we had our flowchart. This is the same thing, but now it's in ActionScript 3 code. So at this point, check your understanding of the material. If you feel you need to review the material again, please do so. If you have any questions, please contact your instructor.